How's everyone going? Wednesday, woohoo! Just realised I've cut off half the screen here. Let me just. I will fix that once we start coding. How is everyone going on this beautiful Wednesday, day 3 of term 3? I wish it was 2023. Then it would be like a whole thing, but it's not. I'm not going to age us an extra year just for the fun of it. Tom, this camera is just not. Sorry, thank you. Okay, so welcome back to the second lecture. Some of you have now had your first tutorials and your first labs, so I hope you've been enjoying them. The slides are on the website. They went up late last night when I realized that I forgot to rename the file to make it available. So please check. Tom will provide a link, in the chat, which will be. Sorry, I keep pointing this way because Tom is sitting right there, which is why you'll see me, pointing at him. And so I will have the lecture notes up earlier than what happened there. It's just been a bit of a crazy week, and so that's why they're on kind of the night before. But I do usually have them up earlier. All right, so on Monday we welcomed and we introduced ourselves. We talked about course admin, and we talked about how COMP1511 works, and also the best approaches to programming. Then we kind of talked a little bit about what is programming, which is something that you're reinforcing as well in your labs and tutes. Basically, you are giving the computer some instructions that the computer has to follow, and without those instructions, the computer doesn't really know what to do because it's not that clever. And then we also looked at, the Linux system and what it is that you'll be using in the labs. So we looked a little bit at the VS Code that you're going to be using as your editor to type your code in, and then we looked at DCC, which is the compiler that you will be using. All right, so what are we going to do today? So much excitement coming your way. Very exciting stuff today. Today we're going to, because at the end of the first lecture we printed something out to terminal. Today we're going to also pick something up from terminal. So take an input, also output to the terminal. Then we're going to learn about variables and how to store information. We're going to talk about constants, and then we're going to talk about some maths in C. So this is really the foundations. This is the beginning. This is the intro stuff. And definitely this is the easier part of the course, these first few weeks. So keep up to date in these first few weeks so that you can then focus your brain power when things do start to get a little bit harder as we keep going through the course. All right, the code today is still in the same place, and Tom is going to post the link in the chat. So in the chat today is just Tom and me. So again, if you've asked a question and no one's answered it, just ask it again, because the chat might have moved on and both of us have missed it if there's a lot of questions happening. So please just tag us and ask your questions. We love the questions. So please do that. Okay, so let's quickly go back to talk about our very first program that we did. And I'm sorry, I can't handle it. Can you please switch off that light? Thank you. Just switch it off. Yeah, that's so much better. Otherwise, it's giving me a weird sort of lightning bolt, Harry Potter style on my forehead. I'm magic. Okay, actually, this is a magic class. This is not really a coding class. So there we go. You're in the wrong place. Or you'll be able to just make magic after you learn how to code. Either way, pretty amazing stuff. So our first program. Let me go back to our code. Okay, so I've actually opened it up this time, and here we go. This was our first program that we wrote on Monday, and what we had. I'll just remind you of these things. This is your first program. And this is called a header of this file. What it means is we just write a little bit about what this file is about. It is for humans only. So when you compile, the compiler will skip any line that has these two forward slashes in front of it, because you're saying it's a comment, it's for humans only. We then had something called a hash include. And that hash include is including a standard input-output library. So it's what allows us to use some functions that have already been written, which means that we don't have to write them or we don't have to think about them. So how good for us, we have to do less work. So we hash include, and then we use the syntax of greater than, less than symbols, and inside it we write the library that we want to include. And all it means is that the compiler will read that line, it'll grab that library, and it will add it to the top kind of our file that's compiling, so it knows what functions we can use. And we will learn more about that in week 3, how it does that. Okay, and then our actual function. Okay, so our function is a block of code that is inside the curly brackets, and sitting inside these lovely curly brackets is some commands. Outside the curly bracket, we have what the function is giving us as an output, so what it's going to return to us. And we have the name of the function, which is the main, and in C, the main is where you start reading all the time, so that's where all the action is going to happen from. And then inside the brackets, we have what inputs are given to this function. So in this case, we're not giving the function anything at all, which means that it's void, which I've always thought is really very aggressive, like just void. You know, it's very deep, it's very dark. So void means you're not giving it anything. It's just a big void of nothing, black hole. Okay, then we have a printf function, and that is inside, this is what we borrowed from this stdio.h, the standard input output. So that's the printf function. And if we want to print something out to terminal, we have a bracket, then we put any text that we want to print out inside inverted double quotation marks. And then this funky looking \n means new line. So it means skip over to the new line after you finish printing. And then every line in C that is a statement that we want to do in the block of code is finished with a semicolon. Always. And the compiler will complain at you if you don't do that. And that is one of the most fun bugs to look for in thousands of lines of code. And then we have a keyword return, because we've said that we're going to return an integer and we're going to return 0. And so I kind of discussed a little bit in the first lecture, is that returning 0 is really saying my program ran beautifully, it finished without any errors, so I'm going to return 0. That's what the 0 is, kind of like the standard way to return 0. It means everything finished, you know, without any problems. And then you can return other numbers as well, because it's an int. An int can be anything, right? And so what that means is, you know, I could return 1,000,000 if I wanted to. The number in there doesn't actually matter. But standard to make the code readable, and there is more issues to it that we will learn later on, you will be returning 0 or 1 for the most part from your main, which means it either finished successfully or it did not at all. Okay. So let's have a look at running this, okay? And then someone actually also asked a good question where okay, so here we go. So I'm going to do DCC, and then I'll do the name of the file, and the name of the file is hello.c. Then I do this O and hello. So someone asked me, why are we doing this O business? What does it mean? So I thought I'm going to show you what happens when you don't do the O. So let me open up a file folder where I am in the directory that I'm in. Now also you need to compile in the directory that the file is located in, otherwise it doesn't know what it is that you are doing and what it is that you're trying to do. So this is the executable file. I'm gonna delete it so that you can see what happens when I run that DCC. Okay, so what this DCC is saying, I'm calling a compiler called DCC, and I'm telling it compile hello.c file, and then I'm giving it, okay, the output file, which is the -o, make the output file called hello. So when I press that, you can see that this hello has just appeared here because I've asked it to make the output file called hello, and then I can run hello, and it will tell me hello COMP1511, yay, excitement. Now what happens if I don't do that O? It's not a big deal, right? Nothing happens. But watch inside here what file is created when you don't do the -o and then the name of the file. it's going to create a file called a.out, which is really the same thing, and you can call it then in the same way, a.out, and then you run it, it will do the same thing. But, you know, it's a lot harder if I have 7 of these C files. They're all going to be called a.out. So you're going to keep overriding it, and it's not very good naming conventions. So this is why we do that -o and then the name of the file, because it allows us to keep that consistency in naming our programs. So, yeah. Oh, someone's asked pseudocode. Of course we're going to do that. I am big on that. You'll see me solve problems just by pseudocode to start with, and then we'll start coding. We will absolutely talk. It's one way to kind of remove some of the cognitive load from the code, where we solve the problem first and then we start writing the code. So we will absolutely be writing things in how we're going to solve it, talk about how we're going to solve it, and then we're going to actually write the code and the syntax for it. Okay, so that's our first program. Seems exciting. In a few weeks' time, you'll be, this will be, you know, I don't know, it'll be like more than a piece of cake. It'll just be like, whatever, this was so simple. So there we go. All right, so let's look at some terminology now as well. So there is, in programming, there is something called a procedure versus a function. So what that means is that you've heard me call that main function, I've kept calling it function, function, function. So a function is basically something that returns something. So it gives us an output and it returns something to the piece of code. Now this bit here is what tells us int or whatever else. It's what's going to tell us that it's returning something, and in this case it's returning an integer. Now when you have something that doesn't return anything, okay, because you can have a program, that a little function that doesn't return anything, that function is called a procedure. Okay, so a procedure is a block of code that you can call to perform a task, but it doesn't return anything. Okay, it doesn't return anything. So when you're printing out to a terminal, you're not returning anything. So print is often a procedure, right? So someone said, what compiling does? Oh, goodness, okay. Compiling is where, okay, so when we write our .c file, we're really writing it for humans. It's, you know, I don't speak ones and zeros. I mean, I could, but it would take me a very long time to write anything. But when we write the .c file or our C file, that's us writing for humans. What the compiler does is it takes that .c file and it compiles it, or what it does is it translates it to a machine readable file, okay? And that's what we then run, that machine readable file. So the compiler is a translator between us and the machine. And someone said, what is pseudocode? That is a great question. Oh, and Tom's just answered it. Excellent. Pseudocode is just, you know, yeah, telling a story before you solve the question, okay? Thinking about how you're going to solve something. If you were in, you know, high school maths, it's when you drew a diagram, that's part of, you know, and then you wrote down kind of the steps that you will follow before you'll solve a question, and then you fill them in. Okay, so a procedure is really just something that doesn't return anything, and a function is something that returns something. So for example, a procedure is going to have something called a void in front of it, because void just means there is nothing. It's the black hole of the earth. We're not going to return anything. So as soon as a function has a void in front of it, it means that it's a procedure, because it's not going to return anything. Okay, and then whatever else is happening. So usually printing out is very much a procedure, because you don't return anything. And then we have a function which does return an int. Yeah. Okay. Now, this is me talking a little bit more about memory. I'm going to keep touching on memory through each lecture, because this is part of the reason that we do C as the language, as your introductory language, so that you can get a bit of an intimate relationship with computer memory, so that you can understand what you do when you play around with memory as well. Okay, so computer memory is a pile of ones and zeros. It's a pile of on and off switches, and the on and off switches is really you know, ones and zeros, because there's only two possibilities. You're either switched on or you're switched off. So it's a choice between 0 and a 1. So we often collect these bits together and to make a byte, okay? 8 bits make a byte. You might have heard about it. Someone was very hungry when they were coming up with these terms. But there we go, 8 bits into 1 byte. Now, the reason you need to know that is that each variable, or how we actually store things in the computer, how we store a variable, so something that changes value, is going to be stored in, in bits or in bytes. And we're going to, start that conversation in a second. So then, just to touch on this briefly, but we are going to have a more detailed lecture about what on earth is a heap and a stack, and a goodness knows what's going on. But when we execute our code, okay, there's two people that are involved, well, two things that are involved in processing the code, and that's the CPU and the RAM. So the CPU is the machine, it's your central processing unit, and it's the thing that actually processes all the instructions and it performs the basic arithmetic. But it's the RAM, so the random access memory, that's what keeps track of all the data that you're actually using to perform those operations, okay? And so that RAM is kind of sorted out into heap, stack, and so on and so forward, where you're going to store these variables, okay? So for now, until week 7, we're going to be sitting in here in the stack, okay? And what that means is that our variables in the stack are made when we start reading our program. When we compile it, we allocated memory. So it's not dynamically allocated, but it's statically, like we can't change it as we run the program. The memory is given out, the memory is already there once we've got our, and that's where Stack Overflow gets its name, because it's a really common error, and I will, in a few weeks time, I'll show you how a Stack Overflow happens. So exciting, so much to look forward to, just a pile of plates coming crushing down, the stack is full. Anyway, so there we go. So that's where we're at. Now, again, don't worry about memorizing these terms. You're going to get used to them as you go on. They're not, no one's going to test you on terminology. That's not really what this is about. But these are kind of concepts that you need to have some understanding of when you start to actually do your programming, because this is the whole point of it, is that you have a basic understanding of memory. Why is there a keyboard tapping sound? Tom is tapping, and sometimes I tap, and sometimes when my nails get long, you'll hear like claws clicking on a clip on the keyboard as well. So that will be super fun. Lots of things to look forward to. And I think also Tom is sitting quite close to the microphone, which is why that's happening. Maybe I'll move it towards myself. There we go. That should stop the clippity clappity a bit more. Okay. Very good. Okay, so now, how do we ask a computer to remember something for us? We put it inside a variable. It's called a variable because it can change its value. So same way as you had, your variables in maths when you were in high school, similarly, a variable here can change values as it goes on and on. So each variable has a certain number of bits attached to it depending what we're representing. And we make these variables with a specific purpose in mind. So you don't start your program by, you know what, I'm just going to make 20 variables and call it a day. I'm going to make 50 variables just in case. That's not very efficient programming, because each time you make a variable, you take up some computer space that's not freed up until you finish running your program. So you're putting quite a strain on, not with 50 variables, you're not putting a strain on memory, but if you start making 1,000 variables, you might be putting quite a strain. So today we're going to start out with 3 data types, okay? Three variables basically. They're going to be an int, which is an integer, and you've seen it used in that int main because we're returning an integer. So an int is an integer. We're going to also look at a char, which is a single character, and it's more than just letters of the alphabet. I'll show you how to kind of look at what chars are. And we're also going to look at something called a double, which is really just a decimal number. Okay, so it's a floating point number. because the decimal point can float about anywhere in that number kind of thing. That's why it's called a floating point number. And it's referred to as a double. Can anyone guess why it's called a double? Because it doesn't feel like, why on earth is it called a double? It's not a decimal, it's not an anything. Why is it called a double? Does anyone know? Trivia, trivia. Yeah, exactly. So it's double the precision, it holds double the amount, so it takes up twice as much space. That's why it's a double. Exactly. So an int is 1, and then a double is 2 kind of thing. So it's double the space. Okay, how are we going to name our variables? What do we reckon? Test 1, test 2, test 3, test 4, x, y, z, and so on and so forth. No, please don't. Please don't ever call your variables x, y, z unless you're doing like a maths equation, unless it's obvious that that's actually what it stands for. So names are meant to be a quick description of what the variable is. Remember that C code that you're writing it for humans. If you start writing variables that are just x, y, z, and so on and so forth, myself as a human will have a hard time understanding what this program is actually doing. So, name your variable based on what on earth it's doing, okay? Name it for someone else, not for yourself, okay? I always find that that's a good way to keep myself honest, because sometimes I do fall into like, I just want to test something quickly, I'll just make it, number 1, number 2, or it doesn't mean anything at x, y, z, let's be honest, because I don't want to type. So we always use a lowercase letter to start our variable name, and C is also case sensitive. That means that if you have a capital letter somewhere in there, it's going to be different to if you just have all lower letters. So they're 2 different variables. There are also reserved words that you're not allowed to use. Things like return, int, double, char. You can't use those words because they mean something in C. So they're off limits. So you really can't use them. And usually we can split words with underscores, long underscore answer. That's fine to do as well. All right, so we name our variables in ways that make it obvious what they're representing. So always think, someone else has to look at my code. I'm going to make it neat. I'm going to make it obvious what's going on. I'm going to make it understandable. Okay, so a whole number with no fractions or decimals, that's an int, okay? So not a decimal, just a whole number. It uses 32 bits, which is 4 bytes. And this is now me telling you that a double uses 8 bytes. Now, if you have 32 bits, what that means is it gives you 2 to the power of 32 different possible values. Now, the maximum value that it can take is very large, but it's not infinite, right? It doesn't keep going forever. The maximum value is really between minus 2 to the power of 31 to 2 to the power of 31 minus 1. Who knows why this minus 1 is here? Why is there 1 less possibilities in the positive direction? What do we reckon? What do we reckon? Yeah, that's right. We can't forget our 0, and because it includes the 0. Well done. So that's why we've got that minus 1, because we can't just, unfortunately, fortunately, we do need the 0. Yeah. Now, a character in C is actually an int, okay, just to make it really confusing. So a character in C comes from the ASCII table, okay, and what that means is that it takes an ASCII value. Now you can look at what the table is, and this is, you don't have to remember all the ASCII values, so you can type a command ASCII, and I always do a -d because it only gives me the decimal values. It makes it much easier to read, otherwise it gives you hexadecimal values. So if you type just ASCII, it gives you the hex and the decimal. So when I limit it with a -d, what it does, oh God, I'm going to clear it, otherwise it's a lot of information. So when I do it with a D, what it does is it just gives me the decimal values, which is much easier to read. So what that means is it gives me all the possible characters that I can have in C, okay? It's from 0 to 127. So all my letters are there, as you can see, my lower alphabet, my uppercase alphabet, but also some symbols are also considered as part of the character subset, right? And also some numbers here as well. But what you can notice is that each letter is actually a number, a decimal value is attached to it. So each letter in C can be represented as a number as well because it is on the ASCII table. There is also, you'll notice some cool things here. Oh, I can't highlight just down one column. I always want to. There's also some cool things here, you know, in this row, some symbols here as well. So there is a few things I'll point out. This is one of my favorites, number 7, bell. You can use that. It like does a little chime. I can't demonstrate it because it's inside the, like I'm currently connected to a virtual computer. So the computer that I'm connected to will chime, which will be of no use to us here. But some of these are kind of like from old school as well, because the ASCII was used, you know, at the very beginning kind of thing. So there's a lot of things like a carriage return and spaces and things like that. And so this number 10 is something that you will use as well. The LF stands for line feed. It's really just a new line. Because it's what you used to do on a typewriter. You used to, you know, move the typewriter down one and over to the side. So that was called a line feed. So you get a whole bunch of kind of these types of things happening. You don't need to remember what they are. You can look up the ASCII table whenever you want. But what it means, because each character has a number attached to it, each character in C can be represented as both an integer and as a character. And what that means is I can do maths, okay, with my characters. That means if I say the letter A and I add 1 to it, it's going to go to a letter B. And that's because a letter A is 65, and if I add 1, I'll go to 66, which is the letter B. So anytime you want to say the syntax for a single character, you put it in single quotation marks. That tells your program that you are on the ASCII table and you're using a character. So those single quotation marks is what tells you you're on the ASCII table. Please, you know, take it and, you know, go and do something with it. And don't worry, we're going to put all of this into code so you see how it actually works as well. Okay, a double is a double-sized floating point number. All that it means is that the decimal point is a floating point. It can be anywhere in that number. It floats about. And, you know, it's called a double because instead of 32 bits like an int, it has 64 bits. So it's 8 bytes. So it's double the size of the integer. Or double the precision, because you can have more, you know, more precision the more digits you're able to store. Okay, so let's look at declaring some variables, and then we will look at printing some variables. All right, I'm going to clear here again. And I'll just resize these, and please let me know if the sizing is okay, if you can see what I'm doing. So I'm going to close this. Don't want to save that. And what I'll do now is, I'm inside here. Yep. So what I'll do now is I'll create a new file. Oh, I'm not going to. Okay, so let's have a file called variable.c, and we're going to practice our variables, basically. Okay, so just let me know if anything is not clear, and let me know if the sizing is bad or whatever, and we can change it quickly straight away. Okay, so first things first. Well, let's have a little header in our file. Okay. Okay. Next up. Sorry, I just got distracted by the chat quickly. Okay, next up, let's hash include, and inside greater than or less than symbols, I'll say which library I want to include. include standard input output.h, so stdio.h, excellent. And then I'm going to start my main because that's the way to start to get going. Okay, excellent. Now, let's talk about variables and the syntax to make a variable. Okay, so what I said is when this program is read and compiled, that's when we make space for these variables, which means that we need to know what kind of data each variable is. So what specific purpose is it there for? Because we need to know how much memory to allocate to that variable. So let's say I want an int, okay? I need to declare that I am having an int. And to do that, I say I want an int. So I've said what it is that I want, int. Then I say the name of an int. This is where I always struggle. I always come up with really bad names. Feel free to suggest names in the chat. Tom is just laughing. He's saying something. I don't know what he's saying. He's speaking very quietly. Age, dog, Steve. I mean, these are all great suggestions, but they're not very good. You know, based on like int dog doesn't make sense because a dog is not an integer. Variable 1 could be a good one. My variable could be a good one. Henry. I'm going to call it something. I'm going to call it my variable. What a boring name. I'm bored of it already. Okay, so I have an int my variable. What that means is that it has now, I've declared that. So that means that 4 bytes will be allocated to something called my variable. It's going to go on the stack, and the stack is going to have 4 bytes for me that I reserved for my variable. Now, to assign a value, I can assign a value to this variable, and I can change it throughout my program. But to assign a value to it, I can say my variable is equal to 5. Again, I just made up this number. That is not a specific number. It's just the number that popped into my head at that time. So to assign a value, you have the name of the variable, then 1 equals sign, and then whatever value you want it to take. Now, that's very good. The other way I can do it is I can declare and assign at the same time. So what I can do is I can say, okay, someone's saying num1. Okay, let's just use int num1 is equal to 5. So I can do it all in one sort of line. I don't have to take 2 lines to do it. And then when I'm changing it further down the line, all I have to do is just say num1 is equal to whatever I want it to equal to. So this is my initial value that it will take. So what that means is then 4 bytes will be saved in the stack for num1, and it's going to have the value 5 sitting in there. I really need to start drawing. I will start drawing soon. After the break, I'll start drawing because I don't think we calibrated the pen. Oh, you get to see my art. Okay, so that's declaring an int. Now let's say I now want to declare that I have a char, okay? To declare a char, same thing. I'm going to have a char. Look at these names. My character. Oh my goodness, I'm just killing it at life. And then I use these single quotation marks to put it in there. Yeah? Okay, excellent. So what that means, and then so here I've declared that I have a char and assigned a value to it in 1 line, okay? I can do it in 2 lines if I want, but it's often much easier to declare and assign at the same time because often the first value you take is going to be 0. Not always, right? It depends what the problem is, but often, and that means that, you know, it's all set in motion. That's the initial value that it starts with. And that means that no garbage is going to go in there because memory is a fickle beast. And I'll try and simulate that happening. Especially in the security lecture, we're going to try and simulate that occurring where you don't assign anything and it just gives it some rubbish from, some garbage from memory. Okay. So that's a character. Great. Now I'm going to declare and assign a decimal number or a double. Okay, so same way as I do the rest of them, I'm going to use the keyword, the reserved word double to say I want a double. That means I want 8 bits. Give me 8 bits, please. My decimal, and then I can assign a value to it if I want. So declared and assigned all on the same line. So this is a way that, and all of these variables live on the stack because the memory for them is given at compile time, right? So memory at them is given at compile time, and that means that the memory is not freed until it gets to this end of the curly bracket. After I finish running my program, that's when we free the memory for it. Okay, so what we can do is what do I do with this? Like right now, I haven't done anything, have I? I've just got some variables. I mean, yay, bravo me. But I really want to be able to do something with them. So let's print them out to the terminal, okay? So, and I'll show you how to print it out to the terminal using a variable inside your terminal. That doesn't make sense. Using a variable, you're going to print out that variable to the terminal. There we go. That makes more sense. Okay, so we already know that to take something out to terminal, we use the printf command or the printf function because it's a function that's inside that standard input-output library. So we're going to printf, open the round bracket. I kept wanting to say curly. Open double quotation marks. Okay, the value of the variable is, and now I want to put a placeholder in to say this is where I want the value of my variable to go. Okay, so if I'm printing out an int, I'm going to do a %d. Okay, that means that is a placeholder for a decimal value. It's going to expect you to say that you need an int. I'm going to do a new line afterwards because it makes it look nicer. And what I'll do is I'll put a comma after my second quotation mark. And now I need to tell it what should I put in here? Because I've said put a placeholder in that's an int, but I need to say what is the variable that's going to go in there. And so I'm going to say my variable. And in this possible instance, I can also say num1 because it's also an int. Okay, great. So now if we try running it, so I'll save it. And now if we try running it, so DCC, the file is called variable.c, and then I'm going to call it variable. Oh my gosh, what was that? Whoa, what is happening? So many errors. So many errors. But they're not really errors, are they? It says warnings, okay? These are really good things to know what's going on. So what does it mean? It's given me a few warnings. Warning, unused variable num1. Yep, I have a variable and I haven't used it anywhere. I haven't done anything with it. That's all that this means. There is the same error over here. The DCC explanation is it seems that the variable num1 declared on line 14, which is just over here, is never used in your program. Try either removing it altogether or using it. Great suggestions. Thanks, DCC. And as you can imagine, it's going to give me the same error for all the rest of the char and the double that I have declared, but I haven't used. So what I'm going to do whilst we practice this is I'm going to just comment out these ones whilst we practice the printf, okay? And then I'll comment them in as we start using them. Okay, great. So now we've also seen these types of error messages. So don't be worried when you get errors and messages. Always go to the DCC explanation and look at the first one, okay? And then after you do the first one, then try running it again. Often the first error is an error also that's causing others as well. So let me clear this again, and I can press my up arrow to call the command back. So using the shortcut, and I'll press it again, and it's giving me the same errors because I forgot to save. very constant thing I forget to save all the time. So I'll run it now, and now no problems, now that I've commented out everything that I haven't used. So to run the file, /, and the name of the program, which is variable, and it's given me the value of the variable is 5, which is exactly what I asked it to print out for me. Okay? Now what happens if I want to print out a char? Okay, to print out a char, what I would do is I'm still using the same printf function, and double quotation mark, the okay, so what do you reckon the placeholder for a character will be? Oh, someone said, why didn't 5 come in a new line? Because I've told it to put a new line after the 5. Okay, so the new line, the line break is after that placeholder. That's why. %C, very good. Well done. So I use %C to do a character. It's quite a nice one. So the character that I'm printing out is %C, but I can also say, and %C, so I've done the placeholder. Now I'm going to do what the thing is called, my character, excellent. But I can actually also print out the integer for it because it's an ASCII value. So the ASCII, and if I'm printing out an integer, I'm going to do a %D. And I can still say my character. Well, it's going to give me an error now, but anyway, we'll get to it when it gets to it. Okay, let's save it. Okay, excellent. So now, what are the questions? Yes, there can be. So the new line is not, it's not a necessity. Nothing's going to happen if you don't have a new line. It just looks prettier when it comes out to the terminal. That's all it does. It breaks it down so that my prompt is not sitting right next to the 5. So it makes it much easier to see what's going on. Okay. Yeah, so it should be stdio, standard input output. Okay, let's compile it again. And so after every time you make changes, you've got to recompile. And let's run it again. And look at this, I forgot to do a new line there. So the value of the variable is 5. Great, we know that. The character that I'm printing out is S, sorry, not C, is S. And then the ASCII value for the character, let's have a look if it is. If it is actually. So let's have a little s 115, yay! So that worked out nicely for us. That was good. Okay, let's go back to the other terminal that actually has, I'm going to close this one, we don't need it. Okay, so that means we've now got a character. Fantastic. Okay, great. I really hate this mouse. I've got the worst mouse ever in this room. Okay, good. So now let's do the double, and I'll show you also how to do to a certain number of decimal point. Okay, how do we use a %D in a char? This is a specific C thing because in C, the chars are ASCII values, and ASCII values are integers. So a char is actually an integer value. And the reason that a char is 1 byte is because that's why it goes from 0 to 127, because it can only store 1 byte, that's as many values as that can take. And it's also the reason we can do very simple maths using chars, because they're really just numbers, they're integers. Okay, great. Let's try the double now. Okay, so again, I'm going to use the printf. And what I'm going to do is the decimal number is Now, what do you reckon will be the thing for a double? Someone's asked, why is there no return in the end? It's a very good question. It's okay. I'll answer it once yeah. So we're going to use a placeholder called, %LF, long float, okay? And then we're going to say my decimal. I don't know why I did that circus voice. Anyway. Okay, let's save that and let's see what it does for us. I did not save that. Okay, so let me try running it again. So I'm going to recompile it because I've made changes, and I'm going to run it again. And I keep forgetting a new line, so it keeps printing out weird things, and I think it's cut off for you as well, isn't it? Okay, let's try this again. I'll do that, and I'll put a new line here, and I'll save it. Look at the efficiency. Save, save, save. And now I will recompile it, and I didn't mean to clear it anyway, and run it. Here we go. Okay, so now it's saying to me the decimal number is 3.140000. That's too many zeros. 4 zeros. Okay, how can I make that look prettier if I'm printing something out? How can I limit the number of decimal places that it's doing? Oh, someone, yeah, almost. Someone's almost got it. So all I can do is I can say in front of this LF, 0.2, and what that will do is it will give me 2 decimal places. So if I do save, and I'll recompile it again, and run it again, it's now going to give me 2 decimal places. Okay, so you just do 0.2 at the front, or 0.3, whatever you want. So if we do 0.3, and save, and clear, and recompile, and run, it's now going to give me 3 decimal places, so 1.40. That's not a weird question at all. That's a great question. We don't have ASCII values for the decimal numbers. So ASCII table is like this. It's got from 0 to 127. You can always look at it. I mean, you can always just Google it as well. It's not a, it's not a problem. You'll get an ASCII table if you Google it, but it's much easier on the terminal. So you go from 0 to 127. These are all the possible values you can have on the ASCII tables. Yeah. So even if you have number 1, okay, number 1 has an ASCII value of 49, which just makes very little sense, doesn't it? And if you ever do the one from the ASCII table, you would put it in single quotation marks, because then you're saying, I want that ASCII value 49. There's not that many times you do that though. How can you print the ASCII value of numbers? So I guess I kind of just said that. Yeah, kind of. It's the ASCII values really are relevant to characters for us, and it allows us to play around with the characters and to do some maths with characters. Okay, so that's our variables and printing them out. Excellent. Okay, yeah, I should have said I can also do more than one variable. Okay, I can print out as many things as I want on that line. So let's say I've got 2 things here. Okay, if I've got the second variable, num1 is equal to, that's going to be really confusing. I'm going to change it to a different number so you can see the difference. Okay, so the value of the variable is blah, and I can just keep going. And second one is, and I can do another %d, okay? And then here, the placeholders, it's in the same order as the placeholders. So if I have %d, this first one, it's going to apply to this my variable here. The second one is going to apply to the second thing I list. So I'm going to say num1, okay? And all that means is I'm now going to print out 2 things, or, I can print out 3 things. I can print out many things. So clear, and let's recompile it, and didn't mean to clear it again, and run it again. And what we'll see is the value of the variable is 5, and the second one is 10. So you can print out as many things. They don't have to be the same type either. You can have a %d and a %c. So I can say here %c as well, and instead of that num1, I can have my character. So you're just using them as placeholders, okay? And save that, and let's clear, run it again. What have I done here? Okay, this is an excellent thing to speak about. So let's look at this error. Variable blah, blah, blah. This is the GCC error. So don't worry, let's go to the DCC explanation, okay? Let's do the DCC explanation. It says, by undeclared identifier, the compiler means you've used a name my character on line 16, which hasn't been defined. Oh, why is it doing that? I've got the character here, but I'm asking for it here. So the way that C reads things is it reads it line by line. So when it gets to line 16, it doesn't know what is happening on line 20, okay? So the only way that this will work now is to move this up the top. And this is often why you see we have all of our variables declared together at the top, and then we use them throughout the program. And it's for this reason, because C reads line by line, okay? And it doesn't know what's happening later on in the line. So now if I save it, and if I recompile it again, well, now it's complaining about num1. I'm just going to comment it out because I haven't used it. Let me save it again, and let me clear this, and let me run it, and now it's not complaining. So now if I run it, it's going to give me, you know, the value of the variable is 5, the second one is s. Yeah. Okay, so how is that? Tom, could you run a little poll for us to see how we're feeling? What's the vibe? Is everyone happy? Someone said, why is the second one %C? So basically I'm trying to demonstrate it doesn't need to be all of the same type. It can be anything. These are just placeholders for variables. So you can have any character or any number or any decimal that you want in there. They're placeholders for variables. Here we go. All right, let's just check that we're at a good... Yeah, so D is for decimal. Well, it's for decimal value, which is really just an int. It's like a full number without decimal points. Even if DCC complains of an unused variable, you could still technically run the... Yes, you can, absolutely. But it's, you know, you can push past warnings and run the program because it's compiled, it's just giving you some warnings. But because C is so, you know, kind of into the memory, you can cause some security issues if you ignore the warnings. I mean, not at the rate that you're writing the programs yet, but as you go on. So it's good practice to clear the warnings before you run it and try recompiling it again. But yes, you can run a program with warnings. You just can't run it with errors. Errors means it's not compiled. Warnings mean it's compiled, but it's got some issues that you might want to look at. Okay, someone said, you can code along with me as the lecture runs. Every time I save, you can see the lecture code as well, update live on the website as well. So I try and save it a lot. Shortcut, just press the up arrow and it will run any commands that you've done before. If you use a %d on a double variable, will it convert to an integer? Ooh, what a great question. Do you know what the best way to find out what it does? I'm going to do it so that you can see exactly what it does. And this goes for when you leave the lecture. You know, don't be scared to make errors. It is the best way to see, you know, to see what happens. And, oh, hang on a second. It's not, okay, hang on. Don't ignore this command. This command is just giving write access to the file. Okay, you should now be able to access it. I've just changed the permissions of it. Okay, so, yeah. Should be able to open it? Tom will confirm for me. Yeah, okay, good, yes. Okay, so let's do it. We've got a decimal, so you're saying let's do, you know what, let's see what happens. I'm going to move this up the top as well. And then what I'm going to do is I'm going to push it to, what did someone want to do? Oh, strings are really weird in C. We're going to do strings, don't worry. But strings are super weird in C. Okay. Yeah. Okay, so let's do it here. This is where I'm printing the double. So I'm going to %D it, and then I'm going to call my decimal, which is actually a double. Yeah? So let's see what happens. File, save, and compile. Aha. What is it telling me? It's saying format specifies type int, but the argument has type double. DCC explanation. Make sure you're using the correct format code. %D for integers, LF for floating point values in your format string on line 28. So that's what it's, right? So that it's given me, so it's given, yeah. So it's given me a warning, right? So then I'll go back and fix it. Okay, someone also said, why aren't I returning anything here? Bit rude of me after I've said you should return things. You should return things. In this particular case, because it's a main function, I can get away. It's bad practice to not return, but I can do it without a return in a main. Okay. C is a complicated language, but at the same time, there are parts of it. It's a low level, high level language. Yeah. But it gives you a really good understanding of memory. It really does. It really has some very good points about it. It really sets you up. So many languages are also built on top of, on how C was written and how C operates. It does have quirks, of course. Don't we all? Okay, I think let's have a 5-minute break so that then we can, so that then we can, let's have a 5-minute break and then we'll continue. Okay, let's 5-minute break. Oh no, I wasn't. I was still on mute as I started talking. All right, excellent. I think a few people have answered it. Yeah. So his garden's twice as big. Can I use Vim? Why would you want to? Okay. I think my file is available. Yeah. It's. I think Tom will put a link to it. Maybe just direct to the file. Thanks, Tom. Okay. Let's just quickly. Someone asked me to quickly summarize what we just did in the first hour, so I'm just going to quickly go over it again, and then we're going to push on to slightly bigger things, a bit more. How can we read something from terminal? Ooh. And then we can really get a party started, because right now we can't really do much, can we? We're still just working with whatever variables we've said are happening, and that's that. Okay, so far what we've talked about is three types of variable, and I'm holding up a whole hand. 3 types of variable. I swear I know how to do 3 fingers. 3 types of variables, and they are an int, a double, and a char, okay? So basically an int is 4 bytes, a double is 8 bytes, it's double the int, and a char is 1 byte, teeny tiny. Okay, so the int is any sort of number, a whole number, no decimal places. A double is a decimal, so a floating point number where the decimal space can move anywhere around in the number, so that's your double. And a char is basically something from the ASCII table, it's a character. So you can see an ASCII table if you want by typing ASCII, and you've seen me do -d just means that I only want the decimal values. I don't want to get every possible value. So it's any character on this table, and the reason it's only 1 byte, it's only 4-bit, only 8 bits, which means that that's from 0 to 127. So 128 is the largest you can get with 1 byte. Okay, excellent. So then what we did is we declared and assigned some variables. So what that means is to declare a variable means that I am telling the compiler that I need some memory for this variable. So that means I'm going to tell it what type of variable it is, because that changes the amount of memory that I'm requesting. So if I've requested an int, that means please store 4 bytes of memory for me aside, and I'm going to use them as the program runs. And what I can do is in the same time, at the same time, I can also assign to it. So I don't need to say int, I can actually just do int my variable is equal to 5 altogether. And what that does is it says, make me a variable, make it an int, so give me 4 bytes and pop 5 into that variable that I've just asked you for. Same with a character. I've got a character. If I want something from the ASCII table, as you can see, I'm putting it in those single quotation marks. And that means that I'm, take that from the ASCII table for me, please. So to declare a character, I use the keyword char before the name of the variable, and then I've assigned a value to it. To assign, it's an equal sign, and then whatever is going on. Okay, then I've got a decimal point number. So decimal is a double because it's double the precision, double the memory space. So you use the keyword double, the name of the variable, my decimal, assigning with an equal sign, and then whatever number I want in here. Okay. Then we looked at our format specifiers. So we looked at using a printf, putting something out to terminal, but also, using those placeholders to actually fill them with variables, because that's really quite a useful thing to do if you want to be writing a program and changing things in the program. You then want to be displaying, what on earth is going on in that program. So to use the placeholders, I have 3 types. I've got a %d, and this is all in the lecture notes as well. So a %d is a decimal number. I know it seems really, weird, but a decimal in this case means that you're printing out an int, a whole number. Then you have a %c, which is a character. So you will print out the character from the ASCII table. And the other one is a %LF, and that's a long float. And what it means is you're printing out a double. Okay, and you can put as many placeholders as you want inside your double quotation marks. You can have %Ds, %Cs, they can be mixed, whatever on earth you want to do. The world is your oyster. As long as the number of these placeholders matches the number of things you have in here that are actually aligning to whatever the placeholder is. So this %D, this has to be an int, and it is, my variable is an int. And then this %C, it has to align to a character, and my character is a C, %C, so that works as well, okay? Okay, so that's really what we've done so far. So we've printed stuff out to the terminal. So now I think it's time to read from the terminal. What do we reckon? Yep. Let's take something out of the terminal. Now, I'm going to introduce another function, okay? And here we have this stdio.h. It was an output library. So far we've done output, we've printed. So now let's read from the terminal. To read from the terminal, okay, we need to use something called scanf. Okay, now as you leave university and start doing, if you do code in C, you're not actually going to use scanf all that much. Okay, scanf has a lot of quirks to it. Okay, it's a funny old function, and there are some security vulnerabilities to it as well. But for our, for us, doesn't matter. Okay, we're not doing anything super duper intense. So we're going to use something called scanf. So for example, let's do, should I open a new file, keep this one as just variables, then do a scanning file? I think I will. I think I'm going to do a new file so that you can save this one, and then you can practice so that I'm not just writing in the same thing. Okay, I'm going to open up a file called scanning.c. Okay, that's the best I can do. Oh my God, short notice. It's a whole bunch of things because when we use scanf, we usually scan in one thing at a time. I mean, we can do more, but it's not particularly efficient, and scanning in a string is quite dangerous with scanf. There's other ways to do it, and we're going to look at it. Okay, scanning, yay. Okay, first up, we're going to have a header in this file. So this program will look at how to scan in things from terminal or user input. Excellent. Okay, then of course we've got to include our library that actually has this function in it, and it's the standard input output library. And now we're going to start our main function. Okay. Okay, so we're going to use this scan. Okay, the F means, why is it printf and scanf? That's a great question. The F means formatted. Okay, that's all the F means. That's why it's printf and scanf. So you're printing out formatted, and then you're scanning in formatted. It's not really anything exciting. I wish I could say the F stood for something more exciting. In computing, the terms are, I don't know, sometimes just super weird, super uncreative, and super unexciting. But at least they tell you exactly what they're doing. Sometimes, not always. Let's not get crazy there. Okay, so if we're scanning something in from terminal, we need to store it in something, right? And after we've compiled the program, we can't just, well, at this stage of the game, we can't just make a variable appear from space to then put out whatever we're scanning into. So we need to declare a variable that we will then use to scan into. So let's declare an integer first. I'm going to do a comment here. I can't spell. Let's scan in a number. Okay, excellent. So I'm going to declare an int and I'm going to call it my input. Just the creativity. I'm sure you're just all astounded at how good and creative my naming is. Okay, what I'm going to do then is I'm going to do a printf and I'm going to write a prompt, okay? Because, you know, otherwise what you're going to see is you're just going to see a blank screen on the compiler that's waiting for you to put something in, but it's not obvious. I'll show you what I mean. So I'm going to say, please enter a number, and I'm going to let it give me, you know, then, okay. So now the time has come to use the scanf function. You use the scanf, and what we do is we have, again, the rounded brackets. Okay, inside here, in quotation marks, double quotation marks, you put the type that you're scanning in. Now, we've already used all our types and format specifiers in the printf, so we now know 3 format specifiers. We know a %d for just a normal number, we know a %lf for a double, and a %c for a character. And that's what we're going to do here. Now, I've declared a variable that stores an int, which means that I'm scanning in an int, so it has to be a %d. Now, after I have said what it is that I'm scanning in, so I'm scanning in a %d, so it's going to be weighting a %d, it's going to be waiting for something that is a number. The same way as in the printf, when I have a placeholder, I've got to say what variable am I using. Similarly, in the scanf, when I have a %d, I've had my format specifier. Outside of it, I need to say, where am I going to scan it into? So where am I going to take like that variable and where am I going to put it? Okay, because right now it's got nowhere to go. So when I'm going to put it in this my input. Now, okay, this is not going to work, okay, and that's because of scanf. In week 5, we're going to learn more about this. For now, I want you to remember this as a syntax rule. Whenever you use a scanf and you tell it to scan into a variable, you got to put a ampersand beforehand, okay? The ampersand means address of, okay? We're going to learn a lot more about it further down in the course, but it really just, what it means is it's giving the memory location of this variable, okay? That's all it's doing. So when you're scanning a number in, you can't just place it in a variable. You need to know the address of that variable. You need to know where in memory it's been created so that you can actually travel to it and give it that variable. So that's why you put the ampersand in front of it. So whenever you scan in, you have the ampersand and then the name of the variable, and that says the address of this variable. Okay, great. So now I've scanned it in. And now what I'm going to do is I'm going to print it back out just so that you can see that it works. So I'm going to say %d, and then here it's going to be my input. Okay, excellent. Let's give it a whirl. Let's try to compile it. Okay, so let's compile it. I'm starting to get lazy. My file name is now no longer called what it is over there. Okay, so now it's saying please enter a number. I'm going to put in a number and I'm going to press enter, and the number scanned in was 13. So the way scanf reads the numbers is that when you press enter, or when you press something that's not a number, it's going to kind of keep trying. Then as soon as it gets to not a number, which is what you told it you're scanning in, it will be like, okay, I'm done. I've scanned it in. Okay. Yeah, I can repeat why we need to add the ampersand. So for now, really, for the first few weeks, just think of it as a rule, as a syntax language rule, right? You know, that's just the rule of the law. You can't do it without it. But what it means is that when you've created this you've given some space here. So after you've compiled it, you created this variable my input, and you created some memory for it. Okay. When you try to scan into it, you can't scan into it without knowing where that pile of memory is. So what you're doing here is the ampersand means address off. You're giving it where in memory this variable was created so that you can place into that chunk of memory that you actually created for it. So what it means is otherwise you can't really do it. Okay, so that's a really great question there. What happens if I'm going to be not that nice, and instead of entering a number, I'm going to enter S, and I'm going to put enter in. Okay, what I get is something called this. It says uninitialized variable accessed, execution stopped, just doesn't look that nice, uninitialized value. My goodness, what's going on? It's not enjoying it. And that's because the format specified did not meet the expectation of what was happening. And so don't worry about that. We're going to learn next week how to deal with that and how to catch that error as well for that user error, because you're not always going to have a user that's just going to put the right thing in. So for now, don't worry about it. It's not gonna, it's not gonna, don't worry about it. Just assume that the user's doing the right thing. To show you what's going on, I'm just going to remove the ampersand so that you can see what error it gives there, so that you are aware what to look for, because it's a really common error to make when you start programming. So I'm going to run that, and here it's given me a warning, format specified type int, but the argument has type, and you're going to see this star. What that means is you've forgotten an address. And the DCC, so you can ignore this bit, just go to the DCC explanation, which says perhaps you've forgotten an and before my input on line 12, right? So it's actually telling you exactly what to do to solve this problem. Bless. Okay, fantastic. So that's reading in a number, okay? What about reading in a double, right? So similar way, you got to declare something to be able to read into it. So let's say we've got double. I'm going to call it my decimal input. And printf. I need to stop making that sound. Someone needs to stop me from making that sound. That's horrible. Please type a decimal. And then I'm going to scan it in. So I'm going to use the scanf function again. In double, inverted quotation marks. What are they called in English? Inverted commas or quotation mark? I'm going to call them quotation mark. Double quotes. In my double quotes, I say the format specifies what it is that I'm waiting for. And I'm waiting for an LF. Okay. And then I'm going to place it into what I've the memory that I've allocated. So this my decimal input. Excellent. So now I can scan that in, and let's print it out as well. So we can print F and so again, same. And here I'm going to do my decimal input. Okay, so let's run it. Let's save it first, then we'll run it. I forgot to replace the ampersand here after I showed you what the error is, so let me replace the ampersand and save that. And let's DCC again. Now we're running, and I'm going to scan, and number 3, decimal 3.14, and then it's giving me, everything happening. Oh, you can't access scanning.c. Okay, sorry, hang on. There we go. You should be able to access it now. Yeah, lots of good questions. Oh, lots of great questions. Oh, I'm so happy with this. Okay. All right. I'm just going to, Tom's answering them, and then he's going to put on the board whatever it is that he feels is so I've put in, what did I scan in? Who knows what I scanned in? 3.14. And when it came out, it just filled everything else with zeros because it's a double, okay? If I only want 2 decimal places, then I'm going to say that I only want 2 decimal places by doing 0.2. And what will happen then is, let me, just not save. There we go. So let me clear this and I'll run it again. And then I'll run it here. So the number is 3 and a decimal. I'm going to do 3.14567, okay? And look what it's doing. It's going to round it for me because I said I've only wanted 2 decimal places, okay? Yeah. Okay, excellent, good, very good. Okay, so that's scanning. Let's do a %C because %C, that's where it gets weird, okay? That's where C really shows you how it's done. Okay, let's do a character. So we've got a char, my char input, print out a prompt. Please type in a character. And then I'll take it in, so, don't make that sound, Sasha. Okay, scanning in a %C because it's a character. And here I'm going to place it inside. So again, I'm going to use the ampersand for address off. Just think of it as a linguistic rule. And I'm going to put it into my char input, which is the variable that I declared to hold the char. And then I'm going to print it out. Okay, great. Let's save it and run it. All right. Okay, here we go. We'll compile it again and run it again. So number, great. Decimal, great. And oh no, what's happened? It wouldn't let me scan in a character. That is so rude. It just kind of skipped over things, didn't it? Oh, you can't see. Well, great. That's really unhelpful. Let me run it for you again. I don't know why that screen keeps cutting off. Very annoying. Okay, number 3, decimal 3.145, and I'm going to press enter afterwards. And look what it's doing. Please type in a character, and then it just goes, the decimal scanned in is 3.15, which is over here. And then it prints out the character scanned in is, and it's got nothing and a blank line. What has it done? What has it done? Why is it doing this? And that is a very good question. This is another weird thing about this scanf. Okay. So, what's it doing? Yeah, that's right. Someone said a new line. It is because a new line is over here in the ASCII table and it's considered to be a character. So what it did is when I pressed enter after my decimal, it read that as the character. Okay? It read it as the character and then it printed it out for me as the character. And this is this new line here that's printed out as the character. Okay? So be careful because these things are, they're not just, like an enter is a character. So it's reading it in and it's saying, yeah, okay, an enter is okay because it's actually a thing. It's on the ASCII table. It works for us. It's not a problem. It's a character. And you were expecting it to be a letter. So there we go. Okay, so how can I fix this? Yeah. We can tell scanf to, I can explain it again, absolutely. Okay, so over here, okay, when I entered the number 3.145, I pressed enter afterwards, okay? And enter, or a new line, a return, is actually an ASCII character. It's over here, it's a line feed. Because it's on the ASCII table, it's considered to be a character, which means it is a valid input for a %C, okay? So it thinks that my enter is actually the %C. So then what it did is it said that is the %C here. It wouldn't even let me type anything in because it read this enter as the input. And then it just printed out this line here, which is this line over here. And when it printed out this line, inside this %C is the enter, okay? And therefore it printed out an enter. It didn't print, that's what it printed out. Okay, by enter I mean my new line. So when you press enter or return on the keyboard, that's what it's printing out. Okay, does that make sense? How's that? Tom, can you just run a poll if that makes sense? Sorry, thank you. No if else yet. If else next week. No, not yet. It's a real weird fix. You'll never guess it. Okay. So what I can do is I can tell right now the order is really bad, okay? Where the %C, I'm scanning it in right at the end. Terrible. %S, be careful of that. That's a string and it's very dangerous. Don't do that. That's got a lot of vulnerabilities to it. But right now there's issues because I'm putting in numbers, pressing enters, %C is just all over the shop. We're not going to ask you to do it in this terrible order. But if you want the scanf, if you want to scan in a character and you want to ignore the white space beforehand, which is what a %D does. So a %D over here, when you're scanning in, this part here, when you're scanning something in, what it does is it's able to ignore anything other than a number when it scans in. And that's because white space is not a number. So it doesn't get confused. It's just looking for a number to scan in, okay? Whereas for %C, because some white space is on the ASCII table, it's a character, and that means that it thinks that that's what it's happening. So we put a space beforehand, and that space, it tells it to ignore all preceding white space. That's the trick. It might not work right now, so if we try it, let's try it, and it's because of the order of things here as well. So if we clear this, over the weekend, I'll really work hard to not make that sound ever again. Okay, so let's do 3.156 and type a character S, and so now it's it's letting me do things. So yeah, printf should, which it did, right? What happened is this printf, the decimal printf is not right underneath, just to make it, here we go. Let me cut it and paste it in here. Okay, so now we've got a bit more, if that might make sense. Oh, thank you. Someone else makes the weird sound. That makes me feel better. Okay, here we go. Let's clear this out. Oh my God. Typing skills, dying. Okay, let's quickly just scan it in again. Sorry, compile it again and run it. And let's just type in. And so now we're working, okay? All right. So that's the magic of scanf, and we're going to learn more about scanf. I've got more weird things about scanf going on because scanf returns some things as well. So it returns the number of things that were scanned. But we're going to look at it next week because I'm overwhelming you otherwise with what scanf is doing. So we'll learn how to check for errors next time. Okay, so we've done variables, which are things that can change their value throughout the running of the program. What happens if I have a number and it's not changing throughout my whole duration of running the program? So what, meaning of life's always going to be 42. Pi is always going to be 3.14151, blah, 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 blah. So what happens if I don't change anything throughout the duration of running my program? It becomes a constant, right? And the way we do a constant is we define it at the top, and I'm going to go in here. Should I do it in variables file? That would make sense, wouldn't it? I'm going to open the variables file again. I shouldn't have done that. I'm just going to do it here. Oh, didn't mean to do that either. So notice when I put in the variable, which is the name of the file, the executable file, it gave me an error because, I can't read that executable file. I need the .c file. That's the file that I can read. So what that means is let's now do a few variables that don't change, which are actually constants because they're constant throughout the duration of our program. So to define a constant, we define them before the main starts. And the reason we do that outside is, if you remember, I've said that C reads things line by line and it doesn't know what happens underneath the line that it is at already. It only knows what's happened above. It doesn't know what happens below. So the way we define them outside the main function, it means that it's available to any of the other code that we have in our program. It's available everywhere for us. So the way I do a constant is I use a reserved word, a hash define, okay? So if I type in this hash define, it means that I'm defining some constants. Now, usually my hash defines, what the naming convention for it, okay, is basically I'll do the words hash define, which means I'm defining a constant. Then I'll give the name to this constant. And the way that we do it is that we type it in capital letters. The reason for this is if you see capital letters anywhere, so a variable name with just capital letters anywhere in your code, then you know that it's actually a constant, and you can quickly look up if you need to, what it's equal to or whatever else if you need to. So it allows you to read the code more efficiently as a human. So define pi 3.1415. So all I've done is I've used this reserved word hash define. Then I've given a name to my constant, and I've told it what the value is. Perhaps I'll also have meaning of life, and I'll give it the number 42. You can have characters as well. It's not a problem. I can hash define a character. Maybe I should learn how to spell. I can do that as well, right? It's not, and then if I want to use it throughout, throughout my, so for example here, I can assign this meaning of life. I just give it the value because it's just going to take that 42 and put it inside this variable, my variable, okay? And then similarly for a double and so on and so forth. So here instead of 3.14, I can just say, actually, I just want that to be pi. So constants are things that don't change throughout your code. They are things, if you have a number in your code that you're not going to change, make it a constant. If you have something in your code that you need to use, but it's not going to change, make it a constant. And you'll see it as we go on, for example, something has 10 rows, that's never going to change. You make that, you define that as a constant. Okay, excellent. So I think, Tom's replied. Good, yeah. Tom's got it covered. Okay, so that's our lovely, lovely constants. We're doing so well here. All right, let's talk about some maths. Because, yay, maths. I've come out of the camera view. Lachlan, good question. We will look at fgets, yes, when we do strings and arrays, but not yet. Right now, we still want you to use scanf because we want you to scan things, sort of little things at a time, and to play around with it. Okay, I mean, I can also do a scanf kind of %D, just like I print out two things. I can also scan in two numbers if I want as well. And we'll look at that. Don't worry, we'll look at it next week. Let's just do one thing at a time. So we can also do some maths. Amazing. Who doesn't love to do maths on a Wednesday morning? I'm going to open up a new file, and straight away I'm going to chmod it so that you have access to it. Okay, I haven't saved it. That would be a useful next step. And then I'm going to chmod it. Okay, done. All right, so let's all right, excellent. So now let's hash include our standard input output library. And we have our main function. Okay, very good. Let's do it. Let's take some numbers, okay, to play with. Okay, I'm going to do some ints to start with. I mean, you can do it with doubles if you know, and I'll show you something as well with doubles, what is forcing and what is not forcing. Okay, so let's do some, you know what, I'm going to break convention. I'm going to use X and Y because I'm doing some maths. So I'm going to say int X and int Y is equal to, I don't know, 10. Wow, really creative numbers. And then I might have a result that is a variable that I'll store something into. So what I've got is I've declared and assigned. So I've declared a variable called X and I've assigned the number 5 to it. Here I've declared a variable Y and I've assigned the number 10 to it. And here I've declared a variable called result and I haven't assigned anything to it. Okay, so now I can do, you know, some maths magic. Now in C, maths is much the same way. You can add, subtract, multiply, and divide. So everything is normal maths. Things happen in normal mathematical order. You can force precedence using brackets, just like in normal maths. So, you know, int result is equal to, I don't know, let's go crazy, X plus Y. Whoa. Okay, and then I guess so that we know what's going on, let's print out X plus Y is equal to, and this is going to be my variable, %D, and I'm going to put the result in here. Okay, so what I've done now is I've said, okay, could you please make my result equals to X plus Y, and then I'm going to print it out here, okay? So let's save it and let's DCC it. Thank you, DCC, for telling me that I need to wake up. Okay, so what it's saying to me is an error redefinition of result. Okay, what does this mean? And here it says note previous definition is here. Now, if you look over here, this actually tells me the line numbers. The error occurs on line 12. Over here on line 12, I've got int result. And it says note previous redefinition is here. So on line 10, I've already defined it. What that means is I've already given it a data type. I don't need to do it again. I can just assign a value to it. So just result is equal to X plus Y. Done. So then save. And I can do int result. You know, I can do it like this, or I can do it just in one foul swoop. Int result is equal to X plus Y. So it doesn't much matter. It's really, as long as you don't redefine it like I just did. Okay, so let's recompile and let's run it again. One day I'll get to the, or not. Okay, maths. and it's giving me x plus y is equal to 15, which I do know, in fact, to be true. Okay, what happens if I do a minus here? Okay, let's see what happens if I do a minus. Amazing. Let's recompile it again, and let's run it again. Look at this, -5. Yes, my computer can do maths. This is quite incredible. What happens if I do a times? It's going to give me something amazing again. I think my computer can do such simple maths. Maybe it can't. It can. I mean, it still says x plus here. It's because I'm not changing the printing here, but I hope you realize that's not. So that's my times, okay? Now, what happens when I do the division? What happens when I do this? What do you reckon? What do you reckon is going to be the result of doing x divided by y? Who wants to take a guess? Yes, yeah. So there is going to be something called modulus, okay, and we're gonna have a look at it. Okay. So I'm storing it inside a %d, so it can't give me a 0.5. Tom really wants to cough, and I'm just watching him go bright red as he's trying to hold it in. Just cough. Okay, so let's do it. So a few people are giving me error. No, it's not going to give 0.5 because it can't be a double. I agree. Absolutely. So let's recompile it and let's see what it gives. Right now I'm doing 5 divided by 10. Oh no, I've gone off. Okay, so well done for all those people that have said 0. It is in fact 0 because 5 divided by 10 is 0, remainder 5. Okay. Now, if you want to do remainder, that's when you use this modulus. The modulus gives you whatever the remainder is. Okay? So now it's going to be the... I've got to stop making that, sorry. Okay, here we go. Let's clear this. Okay, and now let's compile it again and let's run it again. And now it's going to give me 5 because I've used the modulus symbol here. So the modulus is what gives us the remainder, okay? So it's not rounding down. What it's doing is, okay, when I do 5, where's divide? Divide by 10. In real life, I mean, we are in real life, I know, but in real life, that's going to be 0, remainder 5. So what it's doing is it's giving me that 0. So it's not rounding down because it's not a double. When I do the division of 2 ints, what it's doing is giving me what it's actually equal to, which in this case is 0, and the remainder is 5. Now, when I use that modulus symbol, so when I do the 5 modulus 10, what it's giving me is it's giving me this remainder. It's giving me the 5, because that's what the remainder is. So then if I had, I don't know, 12 divided by... I'll go something else. So 25 divided by 12, yeah, that's going to give me 2, remainder 1. And that means that when I do the division, it's going to give me 2. And when I do the modulus, it's going to give me 1. Does that make sense? Yeah. Okay. So what if you use LF instead? That is an excellent question. Okay. And this is what we're about to do. We're about to force a few things. So let's have a look what happens when we force a situation. So instead of an int, I'm going to make this a double. Okay. And here, instead of printing out a %d, I'm going to print out a %lf. Okay. What do we reckon it's going to do now? Do we reckon it's going to give me a, oh, sorry, I'm using like a, this means remainder. Okay, so what do we reckon now? Is it going to give me 0.5? What do we think? What do we reckon? Yeah, a few 0.5s. 0, okay, 0. All right, yep, okay, all right, let's try it. I'm going to run it. 1, 2, 3, enter! Forgot to save it. Just that was an anticlimax, massive anticlimax. Okay, here we go, and run. And What is it giving me? It's giving me 5. Why is it giving me 5? It shouldn't give 5. What magic have I created? I'm good at that. Wait for it, wait for it. I haven't compiled it. Oh my God, thank you everyone. I'm like, it should not be doing that. This is completely wrong. How have I created this monstrosity? Okay, good job. See, everyone is like, yeah, compile. Good. Excellent. Everyone's on the ball. I like to see that. All right, here we go. Now, that was the biggest anticlimax ever. Twice. Here we go. What? What is it doing? It's not being very nice to me. Yeah. It just doesn't want to play. So, what's that one? Oh, that's an old poll. Okay. So what is it doing? Why is it giving me this rubbish? What do we reckon? What do we reckon? Yes, well done. Someone's got it. What it's doing is it's X and Y are still integers, okay? We're dividing an integer by an integer, and so it's giving me this 0 over here. It's just making it a floating point number. It's just giving me a double precision result for it. But it's still dividing an int by an int, okay? Now, if these were doubles, okay, if this was a double and this was a double, so I'm saying they're both decimals now, and the result is a double, now it's going to actually be nice to me. So now if I compile it and if I run it, now it's going to give me the right answer of 0.5. Okay? So when you divide an int by an int, no matter what you do, the result's going to be an int. And when you divide a double by a double, it's going to be a double. So now, where is, actually, you know what, we're going to, I think, we're going to finish, why can't X and Y be ints? They can be ints. It's just that the result is going to be, it's going to divide an int by an int, which means I'm going to get this occurring, okay? It's not going to push the result to a double. So it's the way that C does the division. And what happens is when you keep doing these divisions, okay, you lose precision as you keep doing the divisions because you keep rounding and you keep doing weird things. And what can happen is that you start getting some funny errors, which is actually, that has occurred quite a few times. It's not just where I think I've got, okay. So here we go. I've got a few quirks and I've written them down for you here. And okay, so there's no such thing as infinite precision, which means you can't do a third, right? Because a third is a repeating fraction. So it's 0.333333. Now, if you divide a double by a double, you'll get an approximate number for a third, okay? But the more approximation you do, the worse it becomes, okay? And so that becomes, a problem. So, the repeating numbers are quite weird. So these are the rules, basically. If either numbers in the division are doubles, the result will be a double. If both numbers are ints, the result will be an int, okay? And then ints will always drop whatever fraction exists, okay? They're not going to round. They're just going to give you the whole number from the division, and then you need to use a modulus to get the remainder, okay? So in C, if either numbers in the division are doubles, then the result will be a double. If both numbers are ints, the result will be an int. Okay, and then you might have to use a modulus to do, to actually get the remainder or whatever else. Okay, so that's division, a bit quirky, a bit weird. Now I said to you, you know, you had those into, oh, I didn't do the letters adding and subtracting. I kind of just talked about it. Okay, I'm going to do it. I'm going to do it quickly just to show you what letters do. And it's in maths as well, so it works out. Okay, so let's do, okay, we've got a char, my char, and the char is going to be A. Amazing. Okay, what I can do is I can also do maths on this char because my chars are really integers. So then I can say, okay, char, my next char is equal to my char plus 1, exactly like I would do maths. So if I look at it, what it will do is it will say, okay, my char is A, which means I'll be over here at 97. And if I add 1 to 97, I'm going to get to 98. So I'm going to get to a B. Okay, so if I print this out, I'll say %C plus 1 is equal to %C. And I'm going to call them, well, I'm going to say those are the placeholders for my char and then my next char. Okay, let's save that. And let's compile and we'll run. And I've got A plus 1 is equal to B, okay, which is exactly what I want. Now what happens, I'm not just, you know, just with A's, I guess. What about if I have a capital S? Okay, it should go to a capital T. So it's clear, and we'll compile, and then we'll run, and I'll get S plus 1 is equal to, it's cutting off a bit on the edge there, isn't it? There we go. S plus 1 is equal to T. So fantastic. Yeah, so you can move numbers around as well because numbers are really ints. I mean, I can add more. I can skip a few letters if you want as well. Amazing. So I can, you know, add 2, which means I'll go from S to U. So I'll go to a U, and there we go. I've gone to a U if I've added 2 to it. Yep. Okay, so that's my characters. So now just for funsies, I had a few integer overflow, integer underflow things here. If you wanted to read a little bit more about them, I've got a few trivia things. You know, Gangnam Style on YouTube, it maxed out its view counter because the numbers are finite, the ints are finites. So that's, you know, that's quite fun. So anyway, so basically, you know, have a read, some trivia. Also, we're going to finish up, but I really do appreciate if you have any feedback from the lecture. If you think it's gone too fast, too slow, if you want to cover something else again next week, if you want to go back to something, please let me know. I really do appreciate feedback because it helps me to build my lectures to what you want to hear and what you want to see as well. And better example is, you know, whatever, just constructive. Keep it constructive, things that I can actually act on. And then in my summary of the week, I'll say what some of the feedback was and what I've done to kind of to act on it as well, so that we can keep improving and making the lectures useful for you and make sure that we are, you know, everyone is learning lots and lots of things. Okay, so we're going to finish up there because it's 12 o'clock. Time sure flies when you're having fun. That was super duper fun. So thank you everyone for joining on a Wednesday. I hope that the rest of you have a wonderful time in your labs and tutorials, and have a good rest of the first week. I hope you get all set up. Please remember the forum for any questions, to make sure that you're all set up and you're all ready to go. And then we're going to have a really exciting next week as well when we do some control flow and actually start to make decisions and choices in our programs as well. So thanks so much for tuning in. Enjoy the rest of this beautiful sunshine today.